Hey YouTube, welcome back to another tutorial. In this one, I'm going to be teaching you all about the stock market. Just kidding. This is going to be another Leetcode tutorial, best time to buy and sell stock. So given an array of values, I'm going to show you how to find the maximum profit. So let's go through this problem, go through some examples, and I'm going to give you a real world example, which is going to make this problem seem super easy. So you are given an array prices where prices of I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Let's look at some examples. Given an input of 715364, which represents different days and different stock values based on that day, you need to output the maximum profit. And in this case, it's going to be 5. Why is that? The lowest price you could have bought this stock at was at $1, and you could have sold it at $6. See the explanation: buy on day 2, price equals 1, and sell on day 5, price equals 6. Note that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell. So basically what that's saying is you can't get away with just finding the maximum value in the array and then finding the minimum value, calculating the difference and returning it, because you also got to remember that you can't go back in time and buy a stock. Another example: input price is 76431 and output is 0. In this case, no transactions are done and the max profit equals 0. Now our constraints are prices.length is greater than or equal to 1 and less than or equal to 10 to the power of 5. Prices of I can be between 0 and 10 to the power of 4. Alright, so let's look at a real world stock. I'm going to type in Airbnb stock and let's go through this together. If we go through this stock, you can see the lowest point you could have bought at was right here at 139 to give you the maximum profit here at $212. So if you bought on day 1 and sold right here on February 12th, you probably would have made the most money, despite the fact that the lowest point is right here, 85 USD. If you bought here, you still could have made a profit on July 21st at 148 USD, but it wouldn't have been as large as the original spike. So we're looking for the biggest spike in our array, the biggest difference in values, which goes from left to right, because the stock market doesn't move in reverse time, it only moves forward. Now, another thing you might notice is that when I was going through this and I was looking through all these spikes, you notice that I only went through it once. And that's saying something. That's telling me that maybe we only need one loop. Now, another thing I can infer is that this is going to be a 2-pointer solution, and I'm inferring this because we're going to be constantly comparing two values. We're going to be comparing the minimum value at which you can buy the stock to the maximum value. Let's go ahead and start coding. I'm going to set a variable left equals to 0 and a variable right equals to 1. Now this left equals 0 is going to point to the 0th value of the array, while the right equals 1 is going to point to the first value. And basically what we're going to assume is that the left value is going to store the lowest possible value, while the right is going to store the highest possible value. And we're going to use those two to calculate the maximum profit. So I'm going to set let max profit equal to 0. And we're setting this to 0 because we haven't made any profit yet. And also in the case that the numbers just keep going down, we'll have our max profit at 0 because no transactions will have been done and we can just return that. Now I'm going to set a while loop. I'm going to say while right is less than prices dot length. So we're looping through the array. And the reason we're using right as our looping pointer is because the right pointer is almost going to represent the current day. And the left pointer is going to lag behind and store the lowest possible value, while the right pointer is just going to go through each day. And with the lowest possible value, which is going to be the lowest day you could have bought, and the current day, we're going to constantly calculate what the profit would be. And whenever that profit is the greatest profit we've seen, we're going to make that our max profit. So we're going to start off by comparing prices at our left pointer to prices at our right pointer. Now, the first thing we're going to check to see is, are we even gaining money? So we need to see if the prices at the right pointer is greater than prices at the left pointer. And if it is, we're going to set our profit equal to the prices at the right pointer minus prices at the left pointer. What am I doing here? Basically, we have our current day and then we have the left pointer, which represents the lowest value. So to calculate that profit, we take the current day's value and we subtract the price we bought at. Now we'll update our max profit variable to math.max, which is a built-in JavaScript function of max profit and the profit we just calculated. Now right here, we're assuming that the stock value has gone up. That's why we're saying if prices of left is less than prices of right. Now what we're doing here is we're calculating the profit by subtracting the price we bought it at to the current day price, because we know that it's larger. We know we've had an increase in price. So we calculated that as our profit. Now our max profit is a variable which we defined before the loop, and we're going to keep updating that variable only if the current profit that we just found is greater than any profit we've seen before. That's what this math.max does. It compares our max profit to the current day profit. And if the current day profit is bigger, that current day profit is going to be our new max profit. Now, what if the stock price actually went down or it stayed the same? So we'll say else left equals right. So here you can imagine that you bought a stock and suddenly it goes down in price. What this is doing is basically making up for that. Since this algorithm is like a perfect world where you buy the stock at the lowest price and you sell at the highest, if you run into a situation where the left pointer, aka the day you bought the stock, is greater than the current price, meaning we're losing money, we're going to set left equal to right, which is basically sort of like saying, never mind, I'm not going to buy my stock at this day. I'm actually going to buy my stock on the current day. So does that make sense? I hope it does. So basically what this is doing is ensuring that the left pointer is always pointing to the lowest possible value, so we can seek out higher values for our maximum profit. Now after we're done doing that, we simply increment the right pointer, because this loop is basically emulating time, and the right pointer is sort of like the current day, like I said before, so another day passing each time the loop runs. And when we're done this entire loop, we're going to return the maximum profit. Now let's submit this code. And you'll see I made a mistake right here. I wrote price instead of prices. And you'll see that our code was successful. So let's talk about the time complexity and the space complexity of this solution. So we only have one loop, which is going through the prices.length. So this is going to be O of prices.length, or O of n. Now these if statements, these conditionals are O of 1, so we can disregard those, ultimately giving us a time complexity of O of n. Now the space complexity of this is going to be O of 1, because the only space we've created are these variables right here. We do have the prices array, but that is given to us, so that doesn't count. So the space complexity is O of 1. Anyways, guys, that's going to wrap up the tutorial. Make sure to like and subscribe if you learned something, although you don't have to. And I'll catch you guys in the next one.